today we make our problem doubly complicated. Instead of just one particle, we're going to do two particles. Okay, so let's see what happens if you have two particles now. So, oops, we spelled translational. If you have two particles, then the total energy of your system will be equal to kinetic energy of particle 1 plus the kinetic energy of particle number 2 plus the potential energy of interaction between particle 1 and 2. Okay, so that's typically what you would do anytime you have more than one particle. Just add up all the kinetic energies, and then for all possible pairings of the particle, you get a potential energy term. Now, whenever you have a two-particle problem, two-particle system, it's convenient to write, instead of writing kinetic energy of particle 1 plus kinetic energy of particle 2, okay, it's convenient to do a transformation of coordinates. So instead of a sum of the kinetic energies of individual particles, you write it as the kinetic energy of the whole system, okay, the system as a whole, the pair as a whole. So this Cm right here is called the center of mass. Stands for center of mass. Okay, so you say it's equal to, instead of particle kinetic energy of particle 1 plus kinetic energy of particle 2, you say kinetic energy is the kinetic energy due to the motion of the center of mass plus the kinetic energy due to the motion of the two particles relative to each other. So you call that the internal or the relative motion. Okay, so Kcm here is what we would call the translational energy, the movement of the two particles as a whole. You keep track of the movement at their center of mass. So you track it through the center of mass. And then K internal here, or K relative, that's the kinetic energy that's associated with the motion of the two particles relative to each other. Okay, so internal motion or the relative motion of the two particles.